Okay, so the second limit that you were asked to try in the pre-video notes is this limit, limit of sine of n over n as n goes to infinity. This one can be a little tricky at first because the sine of n is a periodic function and it bounces around between positive and negative values. So that at first might look like we're not going to have a limit. But then this little n in the bottom, right, n is going to infinity, and that kind of overwhelms any sort of bouncing around behavior in the numerator. So the n going to infinity in the denominator is still going to make this limit be 0. So I hope this is your claim from the notes. But let's prove that this is actually the case. Right, so let's consider our sequence, nth member of the sequence minus the proposed limit. So this looks like sine of n over n minus 0. And that's equal to just the sine of n over n. Now I do need to keep those absolute values around the numerator because I can get negative values for sine of n. Now this is going to be a common sort of trick that we use in real analysis. When we're trying to show that something like this can be made small, if we have something that's hard to control like sine of n, we'd make use of the bounds we know for that function. So notice that whatever sine of n is, we know the sign is always between 1 and minus 1. So in absolute value, that has to be less than or equal to 1 over n. Once we have made that step, then we just need to make the 1 over n be smaller than epsilon, and we'll have carried out what we need to do in the proof. So kind of to emphasize that we'll sort of work backwards here, this is what we want. Right? We want to be able to show that the sequence is within epsilon of 0 in this case. So let's see what has to happen. 1 over n is less than epsilon. That happens when 1 is less than epsilon times n. So 1 over epsilon is less than n, which means we can take our capital N, and you can put the subscript or not, but as long as we take a natural number that's bigger than 1 over epsilon, we have what we need to complete the proof. All right, so this is what the final version would look like. Let epsilon be bigger than 0. And take capital N to be any natural number bigger than 1 over epsilon. Then, if little n is larger than that capital N, right, if we go far enough out in the sequence, then it will be the case that a sub n minus L, which is sine of n over n, that will be less than 1 over n, which is less than epsilon by our previous work. As required. So that's the end of the proof.